Hello everyone, welcome to our discussion of section 5.1 in this trigonometry class. So in this course we should be very comfortable with converting degrees or measures of angle from degrees to radians and radians to degrees. So the first thing I want to make sure is that we are able to do that without any trouble. So let's get to that. So using either the radian or the radians or degrees. Okay. In effect, 1 pi radian or radian is equal to 180 degrees. In other words, we can write pi is equal to 180 degrees. So this equality is fundamental in our converting from radians to degrees or back from degrees to radians. So if we have if our desire is to convert from degrees to radians, then what we'll have to do is take the measure of the angle that we are given in degrees, whatever that, say 50 degrees or 80 degrees or something like that, and multiply that by this ratio of pi over 180, right? This ratio comes from that. So if we're going from degrees to radians, then we'll multiply the angle that has been given to us in degrees by pi over 180 degrees, right? So the measure of the denominator here, this ratio in the denominator is in degrees and the numerator is in radians. So multiplying these two terms like this, it will cancel the degrees, and what we're left with is the measure of the angle we had in radians. So let's write that down. So this would be the measure of the angle in radians. Okay, so we have that as one of the formulas that we're going to be using a lot. Another case is when, of course, we're going from radians to degrees. So going from radians to degrees. If that's the case, then, so what do you think? How will the formula work in this way then? Well, we take the angle that has been given to us in radians and multiply it by, can you guess how this will be switched? How would this change? Well, we're going from radians to degrees, so the denominator would have to be radians, so the units would cancel, and the numerator would have to be in degrees. Okay, so in that case, it would be 180 degrees over pi radians. And of course, this will give us the angle in degrees. Okay, so that's how the conversion works. Like that. So let's do a few examples just to make sure that we are able to do this without any trouble. So here's one example. Suppose this up a little bit. So suppose we want to convert 3 pi over 2 radians, 2 degrees. Okay, so the case we have here is what you see here, going from radians to degrees. Great, so we're going to make use of this formula. We take the measure of the angle in radians, which is 3 pi over 2, and multiply it by 180 over pi. So we have radians here and radians here. They would cancel each other out, and we're left with then the degrees measure of that original angle, which was 3 pi over 2. So in effect, we have, let's take this step by step. We have 3 pi times 180 divided by 2 pi, right? So the pi cancels out. We end up with 540 divided by 2, and that is equal to 270 degrees. Okay? I hope this is making sense. If you've already taken chemistry, one of the freshman chemistry classes, such as 102, Chem 102, in that course they talk a lot about dimensional analysis, which makes use of this canceling of the units in order to convert from one unit to the next. So this should make a lot of sense to you if you've already taken that course. If not, this will help that course when you will take Chem 102. Okay, so let's actually, because we're going to, eventually we're going to get to this, so why not start on talking about it earlier. So these angles that we work with in this course, for this entire course, refer to angles within a circle. This angle is not referring to some angle along a straight line, right? So if we're talking about in this whole course, what this degree or this angle does not refer to is something such as this. Suppose if we want to have suppose we have a straight line and we want to know what is the measure of that angle, and I'm using theta, which is the symbol comes from the Greek alphabet. Theta it is often what we use to represent a degree. Sometimes it's this, sometimes another Greek letter. So this theta, whatever that is, that's not what we're talking about, because this refers to the angle between some line and a straight line. So this is not the kind of angles that we discuss in this course. That's very, very important for you to understand right from the start. So what kind of angles then we refer to? Whenever we talk about angles, such as this one, 270 degrees, we're talking about that angle within a circle, namely, and more specifically, the unit circle. The unit circle, all it means is that its radius is equal to 1 unit. That's all it means. So that is x, and this is y, let's suppose, like that. And let me just draw a rough sketch of a circle with dashed line. Something like this. I'm sure a computer would do a much better job than this. But suppose this is some circle, and then this 270 degrees refers to this an angle that starts from the positive x-axis side and goes all the way. So actually, let me use one of my thicker markers here. I think it'll show better on the projector screen. So we would start from here and go all the way around to 270 degrees, that would be the angle that we're referring to. So the blue line, the blue thick line, is tracing this angle 270 degrees. Okay, so that's the 270 degree angle. This is very important for you to remember throughout this course, and that's why I started talking about it very soon in this first lecture series, because depending on where the end of that angle ends up. So if you have an angle whose end point stops here or ends here, that's the first quadrant. So the algebraic sign of the end point is going to be, or what we call the terminal point, will be different, will be positive. Positive x value, positive y value. But if the end point of this angle, or any angle, ends up in the second quadrant, right? We remember from basic algebra that this is the first quadrant, this is the second, this is the third, and this is the fourth quadrant, right? So if it stops here in the second quadrant, then the terminal point has an x coordinate that is negative and a y component that is, or coordinate that is positive. That's why it's important to, right from the start, from this first lecture series, to remember all these angles are within a circle, and that will affect the algebraic sign of what we call the terminal point of that angle. Okay, very, very important to remember that. As a matter of fact, we will get to it later in this first lecture. Okay, so before we go further, let's do another example of the same kind. That is, we go from radians to degrees, and then we'll do some example going the other way, going from degrees to radians. Okay, suppose we're converting 5 pi over 6 radians to degrees. I strongly encourage you to, throughout this course, to pause the video, because it's so easy to do that when you watch the video. Don't watch this like we all would watch a movie without pause, of course. Watch this, repeatedly pause the video, write down on a piece of scratch paper whatever solution you think and then you think should be, and then unpause the video and then compare your solution with what I have. If you do this throughout this course, you will progress much faster and get a better understanding of all the problems that are forthcoming. And as opposed to if you just watch me work these out and try to memorize this, you'd have to have a head as big as this building or this campus to do that. You don't want to rely on memory so much, even though sometimes we will do that. Sometimes we will need to memorize things, but mostly on understanding things. And to do that, you'll need to give your mind the opportunity to solve these problems first before you see my solution. So I hope you'll do that repeatedly, pausing the video as we move forward. Okay, so going from radians to degrees, and I'm hoping you've already paused the video and you have your solution at the ready, and now you want to compare that with this. So we start with 5 pi over 6. We will multiply it, because we're going to degrees, by 180 over pi. So the radian and the radian cancel out. We're left with a combination of numbers that will simplify to a measure in degrees. So let's take this step by step. So we have 5 pi times 180 over 6 pi. So pi and pi cancel out, and we end up with 900, right? 5 times 180 is 900 over 6. And of course, this is 150 degrees. Okay, so 5 pi over 6 is 150 degrees. And how would we, what would this represent? Of course, it would represent an angle within a circle. So let's show that as well. So this question doesn't require us to show the angle within the unit circle, but why not start early? We're going to be doing this throughout this course. Okay, so I'm just going to do another rough dashed circle here. Like this. I'm not very confident in my drawing skills, so that will have to do for now. So from here, from the positive side of the x-axis, from this point, this is referred to as point 0 of starting an angle. And going up to this point, it's 90 degrees. Going all the way to here, it would be 180 degrees. So this is 150, so it'll be somewhere here, right? So if this is 90 degrees, add another 60 degrees to it, so it'll be somewhere here. In other words, the angle would be like that. So if we trace this angle, it would be in the second quadrant. Something like that. And so the arc, the blue, the solid arc that you see, the solid thick arc that you see represents the angle 150 degrees. And we can just say that's 150 degrees, or otherwise 5 pi over 6, right? This is in degrees, that's in radians. Okay, so now let's do a couple of examples going from degrees to radians. We'd like to know how to do that as well. So suppose we want to convert 30 degrees to radians. Okay, so that, let's bring back the one of the previous slides. So going from degrees to radians, we'll take the value in degrees and multiply it by pi over 180. So the degrees cancel out, the units of degree cancel out. We're left with the radian. Okay, so let's do that. So we have 30 degrees times pi over 180 degrees, right? So we end up with 30 pi divided by 180. Okay, so after simplifying, what do we get? So the 30 cancels out with the 30 factor of 180. We're left with 6 in the denominator. So ultimately we have pi over 6 in radians, of course. Right? So 30 degrees is pi over 6 radians. Okay. We did some graphs of the other, so let's do quick graphs of these. I'm going to do one here and a little y-axis here. Let's do a little circle, dashed circle here. Like that. So 30 degrees is between 0 and 90 degrees somewhere, right? So we would say, let's say it would be, since it's 90 degrees from here to here, let's say this would be 1/3 of that, roughly this angle, roughly, like that. All right? So we're talking about this arc. And here we can do that, and here this would be, that short arc would be the pi over 6. So this is what we have at this angle would be as what we have as 30 degrees or pi over 6 radians. Okay, let's do another example. Suppose we want to convert (135 degrees) to radians. Right? So we take the measure of the angle in degrees, 135. We multiply it by pi over 180 degrees. So degrees and degrees cancel out. We will have after simplifying, we are left with 3 pi over 4. And this is in radians. Okay, 3 pi over 4. So let's do a quick graph of this. That, and of course a rough sketch of a circle. Like that. And let's see, so 135 degrees. We know from here to here is 90 degrees. From here to here would be 180 degrees. From here to all the way to here would be 180 degrees. So 135 or 3 pi over 4 is somewhere in the middle. Let's say it is here right dissecting the second quadrant. So if we do something like that. So this angle 3 pi over 4 would be that solid line that you see coming from there. So, and let's label these quadrants like we did before. So here, for example, here that would be the first quadrant, second quadrant, and the third quadrant, and of course the fourth quadrant, right? We're going counterclockwise. Same way here. Okay, so we have first quadrant, second quadrant, third quadrant, and the fourth quadrant. And of course the same thing is true here. We have the first quadrant, the second, third, and the fourth quadrant. And of course what we have here is 135 degrees or 3 pi over 4, which refers to the solid arc that you see. That angle that you see is traced is 3 pi over 4 or 135 degrees. Okay. Because we're going to be working with the circle a lot, let's recall the general equation of a circle. Remember that when we talked about it in Math 124, College Algebra, and also Pre-Calculus 1, Math 126. So let's recall that. Okay, so the general equation for a circle, it was x minus h squared plus y minus k squared is equal to r squared. right? Remember this? So let's also recall that h comma k refers to the coordinates of the center of the circle, and r is the length of the radius. Okay. So given this, then what would be the equation of a unit circle that has its center at the origin of the xy axis? Okay, so therefore, according to this, so let's give that as a note. Given this general equation of a circle, note that the equation of a unit circle and I guess we'll soon talk about the characteristics of a unit circle soon. Let's see. As a matter of fact, right after this, of the unit circle, so this is the unit circle we're talking about. Which is centered at the origin of the xy axis, right? So in that case, h comma k is equal to 0 comma 0, and because it's the unit circle, because of that, then radius is equal to 1 unit. Therefore, we can plug into the general equation of a circle with these values. So we have x minus 0 squared plus y minus 0 squared equals 1 squared, right? Radius squared. So what do we get? We get x squared plus y squared equals 1. And this is the equation of a unit circle. And again, this is very, very important to remember as well. In this whole class, we will use that relationship in one way or the other. So this is the equation of the unit circle. Okay, like that. I guess we can just, since we've been drawing graphs for the other examples, let's do a graph for this one too. So the unit circle, I should have drawn it before this line, but it's okay. Let's just say for the unit circle, we have this kind of situation. So really, this course is really the accumulation of these simple things used again and again and again. So all of this information, if you remember this, it will be of tremendous help to you throughout this course. And I'm talking about something as simple as that, x squared plus y squared equals 1. So you'll see in future how useful that relationship is. And y And so if we have a rough circle here drawn, not a very symmetric circle, but suppose we have this. Like that. And then, so we have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. And just remember, because of this going around circle, you keep changing from the positive x-axis to negative side of the x-axis, from the positive side of the y-axis to negative side of it. You got to be aware of all of this, what's happening as you move around this unit circle in different angles. So this would be positive. This would be positive again on the y-axis. And then, of course, negative x-axis on this side and negative y-axis on this side. Right? And, of course, this is a unit circle. So each of these, so this radius from here to here, it's 1. And this circle is centered at the origin of the axis. And, of course, from here to here is also 1. And so is from here to here and from here to here. Okay, 1 unit. And one other thing that we should mention, so we know that this unit circle has its center at 0, 0, or the origin. We know that it has the formula x squared plus y squared equals 1. We know that the radius is equal to 1. What else we know about it? Well, the other thing we know about it is the circumference of this, the perimeter of this, right? The circumference of any circle is 2 pi times the radius. So circumference of any circle would be 2 pi r, but of course here radius is 1. So in this case, it would be 2 pi for the unit circle. It would be 2 pi. Okay? So all of this is handy information for us to remember. And of course, the graph that I've drawn, the most important part of it is to make note of the transition in algebraic sign from one quadrant to the next quadrant, how x and y change algebraic sign. Very, very important to remember. Okay, that. Okay, so let's make use of some of the things we've talked about here in solving problems. So suppose we want to find the missing coordinate on the unit circle given that a point x comma -7/25 is in quadrant 4. Quadrant 4. Okay. So first of all, let's get a feel for where this point is. And all we need to do is draw a little picture to make us understand this question or problem better, a little bit better. So this is the x-axis and the y-axis. And let me draw a little circle here, like that. And this is, we're told that we're in the fourth quadrant, right? Quadrant 4. We know that. So the point that we're talking about here is in here, in the fourth quadrant. So it would be here. And let's draw it. So we would have some point. Let me just mark it with a big dot here on this circle. So we're talking about that point in the fourth quadrant. Okay? So in the fourth quadrant, the x-axis is, of course, positive, right? And the y-axis is negative. So let's just keep that in mind as we solve this problem, right? In that quadrant, the x, let me actually write it here. So we've been given x, and then comma, negative 7 over 25, right? This is the information we have. Now we know that x has to be positive. Must be positive. Right? Given that this point is in the fourth quadrant, the x value for it should be positive. That's why this is so important information. It tells us what the algebraic sign is. Okay, so the solution of this then, so for the unit circle, what do we know? We know that the equation of the unit circle in general is x squared plus y squared equals 1, right? We know that. Now, we're looking for the x, and we are given for a point that is on this circle with y component equaling negative 7 over 25, right? So let's plug that in and solve for x. That would become, if we plug this negative 7 over 25 into this for y, then this becomes an equation of one variable, and we can easily solve for it. So let's do that. So we have x squared plus negative 7 over 25 squared equals 1. Then x squared plus 49, raise this to, or square this inside, right? The negative cancels out, it becomes positive because this power is even. And then 25 squared is going to be 625, right? So let me just double check this with my small calculator here. So 25 squared is 625. Okay. And that is, of course, equals 1. 1 squared is 1, right? So let's 1 squared here, what we have, and is 1. That's radius squared. It's a unit circle, right? So we know that this is just 1. Okay. So now let's solve for x squared. X squared is equal to 1. We need to, if we're solving for x, then we need to isolate x. So let's move 49 over 625 to the other side. When we do that, this positive becomes negative, right? 49 minus 49 over 625. And then, of course, we have to take the common denominator here. So x squared is equal to 1 over 1 times. The common denominator is 625. So to get that from this denominator here is 1, which I have here. So to get 625 from 1, all we have to do is multiply it by that, 625. But we can't do that to the denominator and not do the same thing to the numerator. So multiply the numerator by 625, right? And then minus, of course, the rest of this, which is 49 over 625. Okay, we're getting closer and closer to solving for x. And then we have x squared equal to 625 minus 49 divided by 625. And then x squared is equal to 576 divided by 625. So now we have to use the square root property, right? Using the, let's write that down. So recall, this is again back from college algebra, Math 124 or Pre-Calculus 1. Recall from that. Recall from, let's say, Math 126, that according to the square root property, what do we have? We have, take the square root of both sides. So if you do that, if we have square root of x squared in order to solve for x, right? And take the square root of the other side, 576 over 625. According to the square root property, according to this, we're going to need to have plus or minus here. Not just positive, but plus or minus. We're going to end up with two solutions, not one. And then on the left, we have just x. On the right, we have plus or minus. Each of these numbers is a perfect square, 576 and 625. So we have plus or minus 24 over 25, right? Of course, we learned, so if x can be one of two things, which one is correct? Well, earlier we did a basic graph to show us that. So we're in the fourth quadrant, and in the fourth quadrant, the x value cannot be negative. It's positive, right? So in here then, so we have because we are in the fourth quadrant, then x can only be positive. So x is equal to positive 24 over 25. So that's the answer for x. So what is the completed coordinate for that point? The completed coordinate then is parenthesis 24 over 25, which is what we were looking for, comma, negative 7 over 25. Okay, that's the completed coordinate for that point. Okay, so that's how helpful the equation of the unit circle was for us. All right, so let's look at some other ideas, some other very useful ideas here that will be helpful throughout this course. So the other thing that we have to be mindful about the circle is movement around the unit circle. So let's talk about that a little bit. Movement around the unit circle. So let me draw a couple of diagrams or graphs here. Draw one here and another one here. So this will be x, like that, and of course, the y-axis. And this one here. And let's draw a couple of circles here. That one. These are supposed to be centered at the origin, and I know I'm off, so please pardon that. But let's assume that these are unit circles centered at the origin. And then, of course, we have the quadrants, so first quadrant, second quadrant, third quadrant, and the fourth quadrant, here, here, like that. So we're talking about movement, right? Key word here is the movement. So if we're moving, the rule here is that if we're moving counterclockwise, as I've drawn these arrows, like that, then that means that we're moving in the positive direction. Remember when we have the real number line, when we move along the real number line, we should know whether we're moving in the positive direction or the negative direction. We should be mindful of where the zero is and how the line is split, right, between the negative and positive values. This is doing the same thing. So here, on a unit circle, even though it's centered at the origin, that's not where the zero is. Zero is here. That's the center. That's the center of the circle, at the origin. But the point of zero is from here. Zero angle we're talking about, right? Zero angle is right there, where the line has not moved. This line that traces an angle has not moved. It's just standing right there at zero. If it's moving, if we trace an angle in the counterclockwise direction, as I've drawn here, and let me actually continue a couple of more arrows here, a few more, like that, then we're moving in the positive direction. So let's make sure that we make a note of that. So counterclockwise movement is equal to movement in the positive direction. Okay? So, and a few other pieces of information we can add to this diagram. For example, this here, that point is pi over 2 radians or 90 degrees. So if you trace an angle starting from 0 all the way to that, you've traced an angle of 90 degrees. If you continue that to here, that would be pi. So pi would be that point, which is equal to 180 degrees. Then if you continue tracing that angle to this point, that would be 3 pi over 2 or equals to 270 degrees. And of course, if you go one full revolution around the circle, of course, you've traced from 0 to 2 pi. Okay? One full revolution around the circle in the positive direction. Now, what happens if we do the same thing but in the clockwise direction? Right? So if we're going in the clockwise direction, let's start from here, going this way. So this way and this way. Like that. So this would be in the clockwise movement, that is equal to movement in the negative direction. Since I forgot to capitalize it, I'm just going to underline it. Movement in the negative direction. So what happens here then? How would these numbers change if we're going in the clockwise direction? Well, again, we start from 0, which is algebraic sign neutral, right? Plus or minus 0 is still 0. Then, if we get to this point, where are we then? If we're not at positive pi over 2, what is this? This would be minus pi over 2. Okay, we're going in the negative direction. So at this point can be, you can call it either 3 pi over 2 or minus pi over 2, depending on which direction you traced the angle. If you went from 0 to this angle, to this point, in the counterclockwise direction, so that angle would be 3 pi over 2, or 270 degrees. But if you went in the clockwise direction, then you've traced minus pi over 2. Okay? So that's the minus pi over 2 angle, going in the clockwise direction. So what happens here then? Well, that would be minus pi, or minus 180 degrees. What about here? That would be minus 3 pi over 2, or minus 270 degrees, right? We're going clockwise here. And of course, that would be going back one full revolution in the clockwise direction will get us to minus 2 pi angle. That's the angle that was traced in the clockwise direction, minus 2 pi. Okay. Okay, so that's pretty much what we need to know about movement around the unit circle. The other concepts that we need to become familiar with are the concepts of a reference number a reference number and the terminal point. So let's talk about that. Or we can pose the question first. We can ask question, what are the reference number and the terminal point on a unit circle? Okay. So suppose, let's just use any example to demonstrate or to describe what a reference number is, what a terminal point is. So suppose let's draw a basic circle again, basic unit circle. Suppose we have this circle like that, and centered at the origin, and this is unit circle, right? Radius 1. And suppose we take one angle, let's say on this unit circle, let's take this angle with an end point on the circle right there, right? Suppose that's an angle. And suppose we can assume this angle to have been traced in the counterclockwise direction from 0 all the way to here, or we can assume it to have been traced in the clockwise direction, which would be negative direction, right? Let's assume that it was traced in the clockwise direction. So let's say that's angle theta, and let's just say this was equal to, so this angle, let's thicken this line a little bit. In the clockwise direction, we went this distance, or this arc distance, right? That's an arc distance, distance traveled along an arc on the unit circle. So we say that angle is minus, right, pi over 6, or 30 degrees, right? Or let's say, or minus 30 degrees, whichever one you prefer, either in radians or degrees. So in this case, so before we describe each of these reference number and terminal point, I want to make sure that graphically you understand what all this means. So the reference number here, or the reference number, let's call it like the book calls it, is the pi over 6. So not the negative, but the pi over 6, the pure angle itself. So let me write that down. So the reference number, or theta equals pi over 6, is the reference number, or reference, you can think of it as the reference angle. As a matter of fact, a lot of times I refer to it, but it's reference number or reference angle. And it's got many, many uses, as you'll see in the coming lectures, in finding out the coordinates of the endpoints and such. So the angle, the pure angle itself, without the negative, is the reference number. So what's the terminal point? The terminal point is, of course, that end point where the angle stops, right there. So that point, that is the terminal point okay? So this reference number is really, when we describe it, is really the shortest distance between the x-axis and the end point, or the terminal point of the circle angle. Let me say that again. The reference number is the shortest distance, I should say, arc distance, not straight distance, but on an arc on the circle, is the shortest arc distance between the x-axis and the terminal point of an angle. Okay? Let's write that down. So the reference number here, I guess we can write it here. The reference number is the shortest distance between the x-axis and the end point or the terminal point of the circle angle, let's call it. Circle, this angle that is associated with the circle, of the circle angle. And of course measured either in degrees or radians, it makes no difference. Either in degrees or radians. Degrees or radians. And of course, this is the terminal point that it's obvious on the graph, and the reference number was a little more, we had to take a little time to describe that one. Reference number is that. It's the shortest arc distance. As a matter of fact, let me add that. It's the shortest arc distance between the x-axis and the end point or the terminal point of the circle angle. In this case, how could you get to this terminal point? You could either go from here all the way around, or you could just go here, right? From x-axis to this. So this is the shortest one. So your reference angle is not this, it's the shortest distance. It's that one. Okay? All right. So there are few very useful special reference angles that we'll be using throughout this course. Let's just list them. And if you can, eventually you'll have to memorize these. And if you do, they help you tremendously in solving problems and so on. But I think we'll do so many problems in this course with these few reference angles. So I think even if you don't want it, you'll get to memorize them because you'll be working with them a lot. But hopefully you'll also make an effort to memorize them earlier. These are one of the few things that are helpful if we memorize them. So note, let's make a note about it. So this is these are the few special reference angles. And we can call them anything. Let's call them T. And their terminal points. Okay. So I'm going to make a table here. That way things are more organized. So I'll start here. Let's make a table of these few useful special angles. So we have that. And then like this. And let's also drop a line from here. Like that. And let's do a line here and another one here. So we need, let's see, 1, 2, 3, 4. I guess we need one here, 1, and then 2. Three, 4. Okay, so this would be the reference number, this column. And this would be the terminal point. And this reference number or reference angle, its reference number is an angle. And so do I need to split this? Let's see, 1, 2, 3, 4. Yes, I guess so. So let me split this right here. Okay, that's better, I think. So this would be, we want to show the reference angles or reference numbers in both radians and degrees. So this would be in radians, and then this would be in degrees, like that. And so, okay, so here are the reference angles. So 0 in radians and degrees is the same thing. And then in radians, it would be pi over 6. In degrees, it would be 30 degrees. Pi over 4 in radians and 45 degrees in degrees. So pi over 3 in radians and 60 degrees. And of course, pi over 2 and 90 degrees. Okay, so then the terminal point on the unit circle, of course, for this, it would be, and by the way, so these are, let me also, so this would be, so the terminal point, this, we want to show this in x comma y fashion. So for this, let me continue actually this line. For angle 0, 0, that would be 1 or 1 comma 0. 1 comma 0. That's where the terminal point is. For this reference number, it is at square root of 3 over 2 comma 1 over 2. Like I said, you'll see these reference angles a lot. So you'll come to memorize these, if not this week, through this course, you will remember these. But it's good to make an effort to remember them anyway. So for the pi over 4 or 45 degrees, it's square root of 2 over 2, comma, square root of 2 over 2. For the 60 degrees angle or pi over 3, it's 1 over 2, comma, square root of 3 over 2. And then, of course, for the 90 degree angle, it's 0, comma, 1. I think it's helpful if we draw these also, because notice that all of these angles are in the first quadrant, right? What do we know about first quadrant? X and Y components are all positive. So just keep that in mind, because if the reference angle is in another quadrant, such as second, third, or fourth quadrant, then the algebraic sign of these changes. And you'll see that in the rest of this course. But we're going to begin with this as the foundation for us to just get acquainted with a few special reference angles. That's all. But remember, the algebraic sign will change if these reference angles are in a different quadrant. But right now, we're assuming that these are all in the first quadrant. So I'll just draw basic graphs for these. So for example, for this first one, for 0, 0, So if we draw a little graph, I'll draw it quickly like that. And if we have a circle centered at the origin, then 1, 0 angle is right here. So the terminal point there is 1, 0. It's at that point. X is equal to 1, 0 because it's on the unit circle, right? This is the unit circle. Its radius is 1, okay? Then we can do another one for this one, for pi over 6. Let's do that on this side so this side doesn't get too cluttered. And then we can do, let's do this one here. So we have the x-axis and the y-axis. And let's draw a basic circle here, like that. And pi over 6 would be somewhere here. Somewhere here. So that's pi over 6. Pi over 6 or 30 degrees. And the terminal point is right there, right? That's the terminal point. And we're saying that the coordinates of that terminal point are as follows. So they are square root of 3 over 2, comma 1 over 2. Okay. So let's do this one, the graph for this one on this side. I want to draw a quick graph here. And a little circle here. Sorry, I don't mean to clutter this, that's why I'm drawing these too small a little bit, but I have little space here left. So for 45-degree angle, this would be something like that. So the terminal point is right there. And we're saying that the coordinates of that point on the unit circle are square root of 2 over 2, comma, square root of over 2. Oops, let me move this a little bit, like that. Right? And of course, this is the reference angle, right? Right there. That's pi over 4, that angle. The shortest distance between the x-axis and the terminal point, which is that. Okay, and then this one, let's see, let me draw that here on this side. We have the x and we have the y. Like that. And pi over 3 or 60 degrees. So that would be somewhere here. Of course, that would mean the terminal point is right there. So this would be pi over 3 or 60 degrees. And that terminal point right there has these coordinates. 1 over 2, comma, square root of 3 over 2. Okay, like that. And of course, probably the easiest of them all is this one for 90-degree angle, reference angle. So we have the x and the y-axis. And here's our unit circle, like that. And so we have, this would be the angle. So we're tracing from here to here. So from here to here, right? As a matter of fact, so let me they're too small, so I can't put too much detail on these, but so this is basically the theta, which is equal to pi over 2 or 90-degree angle. Okay, and the terminal point is right there on the unit circle. The coordinates of that point are 0, 1, right? Like that. Okay. So, I mean, I mentioned this earlier, but it's so important, so let me put this as a note here, right on the bottom, below this table. It's so important. So we say, note, so the algebraic sign of the terminal point or terminal points change according to the quadrant in which they're in. They are in. Very, very important to remember that. And this is, so let me actually box this, because we will do this a lot. So you got to remember this every time. We cannot really afford to forget this. Okay, we got to remember that. This one. Okay, you can see all of these in the table that I drew. Everything is positive because this is all the reference angles. I look at them. Look at all these graphs. They're all in the first quadrant. But if the reference angle is in here, so you have pi over 6, but the pi over 6 is in the second quadrant, then your y value is going to be positive. So you're going to have positive 1/2. But the x value will be negative. So the end point, the terminal point coordinate would be negative square root of 3 over 2, comma, positive 1 over 2 if this terminal point was here. By the same token, if, for example, if you had pi, reference angle was pi over 3, but pi over 3 was in the fourth quadrant, guess what would happen then to this coordinate? The x value would be positive, so you would still have positive 1 over 2, but comma, the y value would be negative. So instead of positive square root of 3 over 2, you would have negative square root of 3 over 2 if this reference angle was here in the fourth quadrant, not in the first quadrant. Okay, and that one, for example. Suppose your reference angle was 45 degrees or pi over 4, but it was instead of being in the first quadrant, suppose it was in the third quadrant, where both x and y are negative. In that case, instead of positive square root of 2 over 2, comma, positive square root of 2 over 2, you'd have negative square root of 2 over 2, comma, negative square root of 2 over 2. Okay? So just be mindful of the algebraic sign changes as these reference angles end up being in different quadrants. Okay, so we're going to do some examples. I should say some more examples here. Okay, suppose in this example, we want to find the coordinates of the terminal point for t equals 5 pi over 6. Okay, so I guess we can, I'd like to, at least here at the beginning, I'd like to convert these radians to degrees because I don't know how much you can follow these degrees in radians, but in degrees, for sure, it's easier for everyone. So let's start. I won't do this all the time. In the beginning, this is being the first lecture I'm doing that. So let's, because we need to determine the coordinates of the terminal point, right? So we need to know where this, which quadrant this angle is in. And for that, I don't want to ask you to do that using radians. Let's convert it to degrees. And then as we get more used to these kind of radian representations, then I'll stop doing that. And probably in the next second or the third lecture, I'll stop doing that. But for now, let's convert this degree given to us in radians to degrees so we know which quadrant the terminal point is in. Because as you recall, we need to be mindful of the algebraic sign changes. Okay, so to convert this from radian to degrees, we will have, first of all, well, we will have 5 pi times 180 divided by 6 pi, right? So the pi's cancel out. We end up with 900 divided by 6, which is 150 degrees. Okay, so this is definitely in the second quadrant. So let's write that down. In the second quadrant. Okay, so if we draw a little graph of this, I'll just draw a quick and small graph right here. Like that. Maybe I want to make this a little bit longer, this y-axis. Like that. And then if we have a unit circle, let's say like this, like that. So 150 degrees would be from here to here, is this being 0, right? Point of origin of an angle, 0. And if it's 150 degrees, so this is positive, right? 5 pi over 6, so we're going counterclockwise then. If it was negative, I would go in the clockwise direction, but it's positive. So we're going 150 degrees in the counterclockwise direction, and 150 would be 90 plus 60 degrees, so right? So this would be here. So this is the angle we're talking about. All the way from here to here. And let me draw a line from the origin, the center of the circle, to this terminal point, like that. So this is the angle that was traced. Theta is equal to 150 degrees, right? So the terminal point is in the second quadrant. What happens in the second quadrant? The y values are positive and the x values are negative, right? So what's the reference angle? Can you tell me, given what we discussed about reference numbers and terminal points, what is the reference angle here, or reference number? Is it 150 degrees? Think about it. is if this being the terminal point, this being the terminal point, and we're looking for the coordinates of that point, what is the shortest distance to that terminal point from the x-axis? Is that it? No, it's this, right? This is the x-axis. The shortest distance to this terminal point is from here to here. So if this is 150 degrees, and we know from here to here is 180 degrees, and from here to here is 150, so how much is that? That is 30 degrees, right? So the reference angle is pi over 6 or 30 degrees. Okay? So that's the reference angle. Let me write that down. The reference number is pi over 6 in quadrant 2. Okay, let me like that. Because of that, we know that. Okay, pi over 6 in the second quadrant. Okay, so we learned, and this is why it helps if we memorize these. We learned that for pi over 6, 30 degrees, these are the coordinates of the terminal point. Square root of 3 over 2, comma, 1 over 2, right? But we're in the second quadrant. So in the second quadrant, we know that the x values are negative, the y values are positive. So if x values are negative, then instead of positive square root of 3 over 2, this would have to be negative square root of 3 over 2, comma, positive 1/2. Okay, so therefore, from this, the coordinates of the terminal point, let me move this up a little bit. Terminal point R this one are negative square root of 3 over 2, comma, 1 over 2. Okay, so that's why we have the negative here, because we're in the second quadrant. Let's do another example. All of this course is very, very procedural. So the more practice you get with these examples, the better and the better you get at this stuff. It doesn't matter how complicated they might seem. They're really not. The more practice you get, really comfortable with answering questions like this. So let's do another example. And maybe another one after that, actually. So we want to find the coordinates of the terminal point for the reference number, well, not for the because we're going to be looking for the reference number. So sorry for that. So for not the reference number, but this angle. Let me, so for t, or for this angle, 7 pi over 4. Okay? So we're going to find, before we can find the coordinates of this terminal point for this angle, we need to find the reference angle, right? So once again, let's see where or which quadrant is this angle located. To do that, let's convert it to degrees. Again, I will not do this in the starting maybe the third lecture at the latest. I will just, we should know where these are without having to convert them without having to convert them to degrees. For example, one easy way of quickly knowing where this is suppose this was 8 pi over 4, right? 8 pi over 4 would be 2 pi. So that's full revolution. So 7 pi over 4 is a little bit short of that, short of 2 pi, or 8 pi over 4, which means this angle is in the fourth quadrant. So we don't even need to convert this to degrees, but I'm sure you'll become more comfortable with these as time goes on. So, but for now, in this first lecture, let's convert it to degrees using the method we learned earlier today. So 7 pi over 4 times 180 over pi. What do we have? We have 7 pi times 180 divided by 4 pi. So the pi's cancel out. And what do we have with 7 times 180? All right, let's find that out. So we have 7 times 180, and it's 1,260, right? So 1,260 divided by 4. So divide that by 4. We get 315 degrees. Like that. Okay. All right, so let's draw this using a little graph. We already know it's in the fourth quadrant, so actually let me mention that just as before. So this is the angle that we've traced, and this is in the fourth quadrant, right? Because up to third quadrant, that would be 270 degrees. All the way to the end of the third quadrant, the angle would trace 270, and this is 315, so it must be in the fourth quadrant. So let's draw a little picture for this. Here's a circle, unit circle, as best as I can draw it, like that. And so 315 degrees would be somewhere here. Let's say somewhere here. Like that. So this is the terminal point. So the angle that was traced, so we started from here, right? This is the 0. What happened was to trace this 315 degrees, we went like this. We went all the way, and we stopped here at 315 degrees. So this is theta is equal to 315 degrees, going counterclockwise in the positive direction. So what's the reference number here, or the reference angle? Is that 315 degrees? No. The reference number is the shortest distance between the x-axis and the terminal point. So the reference angle is this one, right? So that's the reference angle. It's that angle, or reference number. So if this is 315 degrees, then that should be 270. From here all the way to here is 270. Plus another 45 degrees will give us to 315, which means we have another 45 degrees to go before we hit the x-axis, right? So this reference angle is 45 degrees. Remember, all of this is 360 degrees from one full revolution. So if 315 degrees, so 360 minus 315, we have 45 degrees there. So reference number is pi over 4 or 45 degrees. Okay? So that was the easy part, but now we got to remember that we are in the fourth quadrant here. Okay? Because this is in the fourth quadrant, what happens there? The x-axis is positive, but the y-axis is negative, right? In the fourth quadrant. This is the fourth quadrant we're in, right there. Okay, so remember from the table, from this table, right, that the coordinates of the terminal point for reference angle 45 is square root of 2 over 2 comma square root of 2 over 2, right? But if we are talking about the fourth quadrant, then the y component should be negative square root of 2 over 2, right? Because we're in the fourth quadrant. Therefore, we have, for the fourth quadrant, or I should have said in the fourth quadrant, we have this is the coordinates of the terminal point. Parenthesis, the x values are positive, right? So square root of 2 over 2, comma, the y values are negative, right? So let me make this with red, minus square root of 2 over 2, like that. Like that. Okay. Let's do one more example. Of course, I'm trusting that if you guys have questions, you'll let me know, right? You can post them. At the time I'm recording this, we're still in the middle of the pandemic, so I don't know if by the time you watch this video, we're going to be back in the classroom. If we are, you should ask the question in the classroom. If not, you should ask the question during the WebEx sessions, or just type it right underneath the video. You should pose that question. But because this class is so compact or packed with material, so please don't let your questions pile up. This is the first lecture. You need to, before you watch the second lecture video or read the book, please make sure that you clear all your questions with me moving forward. Okay? So here we have this example. Suppose we want to find the terminal or the coordinates of the terminal point for t equals 16 pi over 3. Okay? As a matter of fact, let's start now. I mean, we should be able to find out which quadrant these radian measures are without having to convert them into degrees. We should be able to do that right away. So let's start right now. So what do you think? Which quadrant do you think this is? There's an easy way of really quickly finding that out. So let's do that. I mean, without converting it to degrees, that is. Our solution here. So we know that t equals 16 pi over 3, you can rewrite this, right, as a whole number factor of pi plus a fraction. So, and to do that, so if we have 15 pi over 3 plus pi over 3, we're going to get 16 pi over 3, right? The common denominator, and then 15 pi plus pi is 16 pi. So we can break this up into these two pieces. So what's the benefit of this? Well, 15 pi over 3, that means it's 5 pi plus pi over 3. That is 16 pi over 3. Okay, so using this whole factor of pi, we can easily find out where or which quadrant this angle is. Let's do that. Let's draw a little picture here. And let me try as best as I can draw a unit circle like that. So we know that 2 pi, let's focus on that. Where is this 5 pi? Well, 2 pi would be 1 full revolution. So that's 2 pi plus 2 pi. So another second full revolution around this circle. That's 4 pi. If you go around the circle twice, you've traced 4 pi. Another pi, that would bring you here to the end of the second quadrant. That's 5 pi, and then plus pi over 3. So plus another 5 pi over 3, which is that, like that, right? So after 2.5 revolutions, that's 2.5 revolutions around the circle plus pi over 3. So we know that that is pi over 3. And we are, most importantly, is that what we did, the result of this is that we're in the third quadrant here. So what happens in the third quadrant? Well, the x-axis is negative, and the y-axis is negative. Right? So let's just, because the only reason we did this, that we broke the 16 pi over 3 into two pieces, one with a whole number factor of pi, is that to discover or to find out in which quadrant we are. So in quadrant 3, that's where we are. That's where this angle is, which we have traced it here. So that's the terminal point, and we know that the reference angle is the shortest distance between the terminal point and the x-axis. So our reference number is pi over 3. Okay, so let's write that down. The reference number is equal to pi over 3. Of course, remembering that we're in the third quadrant, so everything should be negative. Well, we haven't yet memorized this, but for pi over 3, what do we know? For pi over 3, the coordinates of the terminal point are 1/2, comma, square root of 3 over 2. Again, this is in the first quadrant where everything is positive, but we're in the third quadrant where everything is negative. So we're going to have, for our example, we're going to have negative 1 over 2, comma, negative square root of 3 over 2. So, therefore, the terminal point is at and I want to use a different color, red preferably, to make this stand out because this is critical. So we have negative 1 over 2 comma, again, negative square root of 3 over 2 for the coordinates of the terminal point. Okay? So I don't know if you're used to watching academic videos like this or not, but this is something that we ought not to watch like a movie. So what does that mean? It means you don't want to watch it just one time. You want to watch it multiple times if it's necessary. It's quite normal if after watching this video once you feel that there are things that you're not clear about. That's quite normal. And so watch it again and as many times as it's necessary, and pause. I can't emphasize this more, that during watching of the lecture videos throughout this course, pause the videos repeatedly and solve these problems. I did a bunch of examples right now. Solve them on a piece of scratch paper on your own before you watch my completed solutions. Okay, that's the path to move forward so that you can get your time's worth as you watch this video and as you work through this class. If you just watch the videos and try to memorize things, that won't help you much. So pause the video, solve the problems, then compare your solutions with mine. I want to thank you for persisting through this video until the very end. For now, have a nice day, and I'll see you again next time.